Well, hello folks. What I have here is an MRC Tech 7 power pack. A friend of mine sent this over to me because it has a problem. And it's a problem that's common to, happens to more models than just the Tech 7. And I thought, well, instead of just fixing it, I'll make a short video and try to show folks the common places that these things fail. And if you're willing to get inside and do a little bit of soldering, ways you can fix it. So, we turn the pack on. I have the momentum turned off. And the throttle's at 0, and as you can see I have a lamp connected to the track outputs, and it's certainly not at 0. In fact, it's pretty much full on. And as I turn the dial, it has no control whatsoever. It's just full. And here and there you can see an intermittent, see there, it'll go out, then it'll ramp to full again. Pretty common problem. There's two parts inside the pack that most often cause this. And so I'm going to take it apart and show you how we test for them and how we can fix them. Okay, so the first thing we have to do is get inside the case. I shouldn't have to warn people, but I better warn you. Make sure you unplug these things before you start opening up, okay? Now, the problem is it's held together with 4 screws down in these holes, but there are always some kind of a security screw. The kind on this one is, I'll see if I can get a good focus on this, see if the camera will get me here. Maybe not, but it's the type that has, it's a slotted head, but it has an obstruction in the middle, so you can't just put a flat blade screwdriver in it. And so all I've done is I have a handy screwdriver that I keep around. I think you can see it right there. I filed a notch in the tip of it, and that engages this screw right over the little obstruction, so you can turn these buggers out. Now after you do that and get them out, you can put them back in. Personally, I like to just put regular Phillips head screws back in them so I don't have to battle with them again. So once you have a tool like this, you can also buy a tool like that that's ready-made for taking these kinds of screws out. You take these 4 screws out, and then we're going to take the case apart. Get the screws out of there, and just kind of lift the back right off like this. And the only thing on this particular one that's connected is this one small part here. This is the overload device. They don't use a fuse anymore. This is a solid-state auto-resetting thermal fuse device. So I'll just lift that out of there so we don't have to fight with the case, and we can lift it out of the way. The next step we have to take is we have to get the circuit board out, because what I'm after is the rotary control, the speed knot or potentiometer, because that's one of the main failing points that causes this problem, and it's underneath here. So I'm going to have to take some of these screws out to get to it. And first we have to remove the speed knob from the front. Usually these just pull right off, like so. And then a little bit of you can use a wrench or a pair of pliers. Just have to remove this nut from the front of the pot. Okay, now that's released the control, and in fact released the entire thing in this case. There we go. Okay, so this is the component that we're after. The common failure point is these things, it's a potentiometer, and if you know electronics, you know exactly what that is. But in case you don't, it's a device, it's a variable resistor, and it has a wiper inside that rides on a carbon or a ceramic resistive coating. And sometimes the coating either breaks down, or it develops dead spots in it, or broken spots in it, or the wiper itself loses its springiness, so it no longer touches well. And essentially this thing begins operating as though the control wasn't even there at all, and it was just wide open all the time, which is the behavior we're seeing from the lamp. So I'm going to take this apart. We're going to have to unsolder it, and then I want to show you how to test it. So I've got this thing over on my workbench, and I've got the control. I've just got it in a pair of grippy tweezers that sit on the bench, just so I can keep it, I can hold it still while I work on it. And I like to use this thing. This is a vacuum solder device that you can use for removing solder. Some people like to use a solder wick or even a wet sponge, but the idea is you're going to wet the solder, and I'm going to just suck it out of the joint, and you can use, like I said, a wick or a sponge, however you prefer to unsolder joints. But there's an awful lot of solder on these, so you really have to get it off of there. See, You see that gets rid of almost all of it in one go. And I'll just do a couple of more applications, keep sucking the solder off until finally I can get all of them loose, and then the control just drops right out. Okay, so once I've got the solder all removed from the back of these joints, then you can just get into here gently with a screwdriver, and these will just pop right out, like so. You know, you want to do your best not to destroy this thing getting it out, because, you know, we don't know for 100% sure that this is really the problem, although I highly suspect that it is. I've got a analog test meter here. I do have digital meters, but for this kind of thing I actually prefer to use an analog meter, because when you're testing for resistance on a device like this, and if the device is intermittent and wonky like these are when this problem occurs, sometimes the digits on a digital meter jump around and you really can't tell what you're looking at, whereas the slower damped motion of a meter, I think, shows you more of what's happening. So we're going to put the probes on the center lead and one of the outer leads. Now this is a, on the back of this thing it says B2K, and that means it's a 2000 ohm linear taper potentiometer. And as you can see, just even me just jumping around, holding it like this, the meter's jumping around all over the place, and that's a very bad thing. It should have a steady resistance. The idea is, what you want to see is that when it's turned all the way to one side, you should see 0 ohms, and as you turn it, it should sweep smoothly all the way to 2000, which on this meter is right about here on the scale I have it on, okay? When it looks like it's behaving here, okay, but it's deceptive, because all I have to do is just touch it and you can see what it's doing, okay? And you can imagine what happens when it's sitting inside the power pack and it just has a knob on it and you're leaning on it and you're turning it. This is really bad behavior for a control pot. So then we'll do the same thing similarly. We'll have the center lead again to the other side. So it's always the center to one and then the center to the other. And you're measuring, you want to see smooth resistance change across the range from one end to the other. And again, this is at 2000, and as I back it off, yeah, it shouldn't do that. It should back off smoothly all the way to 0, and it clearly isn't doing that. So it's pretty obvious that this control is shot. Either the wiper itself has lost its spring contact with the trace inside, or it could be any number of things. And you can, and this, especially for these larger ones, there's metal tabs. You can bend them back, take the whole thing apart, and try to clean the pad inside with alcohol and put it back together. Sometimes you can make it work, but in my experience, once this starts to happen, if you take it apart and fix it and get it to work, it'll be a very short time after that when it'll just go bad again. So you're really better off replacing. And these parts are commonly available for only a few dollars. For this particular one, so what you'd want to search for on the internet or on eBay is 2K or 2000 ohm potentiometer linear taper, and that's what the B code means, where it says B2K. And then you also want to look for something. This has a 1/4 inch shaft. Sometimes their spec is 6 millimeter. Either way is fine. And a similar hole size to this. It doesn't have to be perfect, but you want it close. Usually these are something around 3/8 or 1/4 inch. It could be anything, but you don't want the tiny shaft. They have ones that will obviously be different. So measure this. Look for one that's close in physical size. It's not a critical component. The only things that are really important are that it's 2000 ohm linear taper, and it's something this size is about a 1/2 watt power capacity. So that's what you should generally look for something like this. And I happen to have a few in my stash, which I'll show you in a moment. So it looks to me like this is our problem right here. We don't have to dig any deeper. So here's a control that I happen to have that will do the job, and you can see it is not exactly the same physical size and diameter, but it's still a large body device, and it's a 1/2 watt, and the shaft diameter is about the same, and it's a linear taper 2000 ohms. So those are the only things that really matter. On this particular device, since they have a flatted D-shaped shaft on here that fits into the knob, that means I'm going to have to use a file or a Dremel or something and cut part of this away to make it exactly match so the knob will go back on. Again, these are all things that you can consider when you're looking for the part. But if you can find one that has a ready-made, they call this a D shaft on it, great. If you can't, you'll just have to, you'll have to makeshift it so that the knob fits. And on this one, you can see it's marked there, B2K. I don't know if you can see that or not, but it's right up in there for a similar device. So I'm just going to have to adapt this a little bit, make the lugs fit back, spread them apart a little bit, and get them in there so I can solder them. And I'll show you that one. Now you might ask, oh, well, yeah, I said there were 2 possible problems. There is. Another common thing that might go bad This device right here is the main power output transistor for the device. These could go, and then you might see nothing, or you might see full output all the time. You wouldn't see this kind of intermittent jumping around, I don't think. You generally see nothing or full steady. And again, these are also pretty cheap parts. You can find there's a number stamped on the device. I think for this is the 760 series. I think this would be like a TIP 142, TIP 142 device. You just have to take the number that you find on the front of this and hunt down a suitable transistor that's the same. And then again, you're going to be soldering small leads on the board and putting it back together. If you don't feel comfortable doing that, then you're probably stuck at this point. This part is more like you've been seeing me do. It's more like big lugs and wire soldering, so it's not too bad as long as you have basic soldering and mechanical skills. I think you can do it. So I'll solder this back in there, and then we'll look at how it does. I thought I'd better give you a quick look at how I'm modifying the shaft on this, just in case you have to do this. It's straightforward, but it requires some patience. Now remember, this is the original one and has that flatted side, and it's very important that we end up with the flat in the same rotational orientation, because the knob is going to only go on one way. It has a D-shaped cutout, and you want the knob orientation to be on the front panel, sit at 0 at the right place, and so it's very important we get the flat in the same position on our new pot. So on this one I have rotated it all the way to the left, and I sit it like that. I do the same thing with this one, and then I match these up like so. And I think you can see I've already started shaping it. There's a little bit of a flatted area here. So I've got it set, and I can see that that cut through the shaft is the parallel line. I want to pretty much file parallel to that, taking off material from this side here. So here I've got the pot, and I've got it clamped in this little vise by the lower half of the shaft, with the place I want flat sitting straight up in the air, so I can just flat file it. And I'm showing you, I'm trying not to use exotic tools. I mean, I have a small milling machine, and I could clamp it in there and do this in a minute, but I want to show you how to do this if you have simple hand tools, a vise and some files. And so you set it up so that you're going to want to file straight across the top, and that's going to get your flat where you want it to match the old control. And now I can just work, you know, I'm trying to keep my hands out of the way here, but you get the idea. You want a flat file right across here, and then periodically check it by fitting the knob to it until it just fits and it's nice and snug. I think you get the idea from there. Now I've got my filing almost down to where I want. I'm just finishing up. I've been testing it in the knob, and it fits a little bit tighter than I like, so I'm just going to file a little bit more off of here. And another important aspect of doing it this way is you're clamping that shaft in here, so you're filing away and you're not putting any load on the shaft and the mechanism inside here, because you don't want to be doing this to it. That's how the old control gets damaged by the knob. You know, after a lot of use, it gets pushed back and forth, and the control that's in there originally is not very well made. So a little bit of wiggling and use over a couple of years, and it starts to move a lot side to side, and that's what causes the internal contact to be lost. So now that we've got this off of here, what you're going after is to get it to fit right in that D-shaped hole, like so. Just a little snug, not too snug, not too loose. So that's why I say file it and test it as you go. And so there you go. And now this will work just like the original dial did, except that this control isn't bad. Okay, so I have the new pot soldered back in here where the old one was. Because it was a different physical size. Remember, this old control was a bigger disc shape. The lugs were spaced a little wider. So in order to make the lugs, I had to, you know, use a pair of pliers and gently spread them and bend them a little bit to get them down into the slots, and then solder them from underneath. But once the control's in place, now I've plugged it back in, and I'm gonna say this right at the outset. If you don't feel comfortable doing that, do it after you put it all back together. But I like to test this thing before I go putting it all back together, so I know that it's fixed. Just be careful what you touch. Remember, this is the power switch. This line cord I'm sorry, I wasn't showing that. There's the power switch. And this line cord is 110 volt plugged into the wall. So you don't want to touch any of these contacts. You want to be very careful when you throw the switch, not to touch anything under there. Just a word of caution here that I've done. So I've got it plugged in and it's switched on. I think you can see the pilot light. That's where the pilot light will be when the case is back together. And here's my little test lamp, which is still connected to the terminals like it was before. And now we can just try it by turning the speed dial up and down. I think you can see that it's gradually increasing the lamp as I turn the dial. Full voltage right there. And then as I turn it back down, nice and gradually, the way it's supposed to work, it just gradually turns off. Unlike before, when it was just, jumping and scattering all over the place and was full on a lot of the time. So, I'm pretty sure, once again, that the control was the culprit here. The first step in reassembling this is to put our new control, which was where the original control pot was. It goes through the hole right in the case, and then it gets tightened on the front with a nut. And I'm only showing you detail on this particular step because from the front, I think you can see this, the original control was a bigger diameter one than the one I'm using as a replacement. Now if you get one that looks exactly like this, same diameter, then everything will be easier for you. But since I'm just using one that I had handy that's the right component value, it was a little bit smaller diameter, and so this is a little metal tab here which keeps the control from spinning around. Even after you put it through and tighten the nut on it, sometimes these things will move. So of course my little tang does not line up with the hole that was originally in the case, so I just use a small hand drill, something like a pin vise like this, to make a couple little holes and then gently file it out. So I made a new notch right there to line up with the new one on my control. And then I just pushed it through and attached it in place with the nut like so. I just wanted to give a word of caution, a few general guidance pointers about putting these things back together. Now your model might not be a 760, so it might be slightly different. But the key is take notes or take a picture when you take it apart, because it's easy to forget things like which way a wire went or where the transformer, maybe you had it flipped over and you forget. It's particularly important to get the high voltage wires run through here. These go through passages as a strain relief to keep them from getting jerked out of the case. You want to make sure you put those back in the way they were. And it also makes it much easier to put the whole case back on nice and neat with nothing being pinched or jammed in the process. So now we're back. Got the case put back together, and as I mentioned earlier in the video when I started taking it apart, I didn't use the original security screws. I just put regular screws back in it so this thing can be taken apart more easily in the future. I put these I found them at the hardware store and found some nice nylon washers, and the reason I put them on there, we discussed this earlier but I'll show you here, is that now when the dial is placed on our shaft, remember we shaped this and this now fits right on here. Well, it does on us. There we go. Okay. And the reason is now the control itself rests and rides on those nylon washers, so you don't have any of this tendency of the use of this thing to wiggle the shaft of the potentiometer back and forth, which does lead to it potentially failing early in its life. And so now when we turn the dial up, I've got my bulb still connected, you can see that it just sweeps up nice and smooth. There's no dead spots in the rotation, no place where it just drops and goes to zero. It's not constantly full all the time. So the pot was definitely the issue. And speaking of that, I disassembled the old control. You can take these apart by just, you can see this, get close enough here, but there's 4 little metal tabs here, and you can pry them out with a small pair of pliers, and then the bottom just pulls right off of these. And what I discovered inside, here you can see some of the things I was talking about. So you've got a wiper here, and it rides on this carbon-coated trace. And very often what happens is this thing gets chipped away, or it wears out, or it gets dirty, and that's when you start having problems with the control. In this case, it wasn't the reason it failed. I cleaned it all up, and it still didn't work. And the real failure point was right here, where these 3 terminals contact the trace material. They're just crimped in place, and they rely on that to make contact. You can't solder to that stuff. It's just like a chemical coating. So these things they weren't loose, but they had lost their contact with that chemical, and so they didn't work. And I could put the meter on and test them and then wiggle them and make it sort of work for a while. So what I did was I took some silver conductive epoxy, and you can find that stuff online if you look around for conductive paint or conductive epoxy. Some of it is based on carbon, which is less expensive. Some of it, I really like the silver-based stuff, although you'll spend anywhere from $30 to $50 for a bottle of that stuff because it's expensive. And I just coated them over, and that restored the contact. And as it turns out, I did that, and the pot now works just fine. I would still worry, though, that over time that epoxy coating is going to break or flake off or crack, and that this thing would just fail again. And that's why when this happens to these controls, for as much as they cost for just a few dollars, it's just not worth it trying to resurrect one of them. So that concludes my little presentation on these. I hope you found the information useful. And as I said, it's something that commonly fails on these, and it's something that you can fix if you have some basic soldering and mechanical skills. Not too afraid to work at the screws and get these things apart. It's really not too tough to fix once you've seen how to do it. Thank you for watching.